Hello everyone, welcome to Sangam tutorials, Gubbi online classes for Ncert and 10th standard, Mathematics and Science. Right. So in the last session of Mathematics class, we had solved problems on Thales theorem and converse of Thales theorem. So all the problems which were involving numericals, and we came across some riders, very important riders, and also we came across some identities. So prove that problems, I am going to call them as riders, and show that problems, I am going to call them as identities. And apart from that, some triangles were given, and three elements were given, and you used to find out the fourth element, that is by using Thales theorem. So all the problems are very important, especially, I am repeating this, especially very important problems are riders, which are like show that on trapeziums. So you have to practice all the problems of trapeziums, which are riders, and also there are some identities on trapeziums. You have to practice that well. So please watch the video once again. Some 4 to 5 trapezium problems are solved on board. You have to practice that. Unless you get a good hold on that, you will not be able to solve further riders on today's theorem. So today we are going with a very important theorem that is based on similarity of triangles, that is called as AA Similarity Criterion theorem. Right. This is a very important, very important concept. The most probability of getting a 4 marks theorem in the examinations will be this theorem. So most probability in most of the exams they have asked this particular theorem for 4 marks. So this is very, very important. So to learn this theorem very well, to understand this theorem very well, you need the knowledge of Thales theorem and you need the knowledge of the converse of Thales theorem. So both are done well, you have understood well, you have done a lot of, that is some worksheets on this. So very important concept you have to remember. So once again I will recall the things. One is, if a line is drawn parallel to a side of a triangle, then it divides the other two sides in the same ratio, that is proportionally. This is called as Thales theorem. So next one is the converse of Thales theorem. If a line divides any two sides of a triangle proportionately, then it is parallel to the third side. This is called the converse of Thales theorem, which is very, very, very important. So apart from this, let us go to some previous classes, what we had learnt regarding similar triangles. So, if you want to prove any two triangles to be similar, we have to prove that they are equiangular, or we have to prove that their corresponding sides are proportional. So, out of these two concepts, either you have to prove any one of it, but not both. So this is the uniqueness of triangles. Apart from triangles, if you want to prove any two polygons of equal number of sides similar, then you have to prove both the things. That is, you have to prove in that polygon, you have to prove that both the corresponding angles are equal, as well as their corresponding sides are proportional, in order to prove that those two polygons are similar. But in case of triangles, you need not prove both the criteria. That is, you need not prove that is both the conditions. That is, only one condition is any of the one condition. That is, either if you prove that both the triangles are equiangular, then their corresponding sides will be proportional, hence they become similar. So if you prove that their corresponding sides are proportional, hence their corresponding angles will be equal and they become similar. So either one of it we have to prove it. So if you want to prove that any one of the condition is enough, not both the conditions are required, then we need the help of Thales theorem and its converse. So before coming to AA criterion of similarity, we have learnt Thales theorem, we have learnt its converse, we have learnt its corollaries, we have solved numericals on it, we have solved identities on it, and we have proved riders on it. So this is the entire criteria we have done, and we have successfully finished that, and now we are at the step of proving that to prove that any two triangles to be similar, just one condition is enough, not both. So among those two conditions which we are taking in this theorem. So in this theorem we are going to take, if two triangles are equiangular, then their corresponding sides are proportional, or if two triangles are equiangular, then they are similar. So if two triangles are equiangular, automatically their corresponding sides will be proportional, so therefore they become similar. If the corresponding sides are proportional, automatically their corresponding angles will be equal, hence they become similar. So we are going to prove the first criteria here. If two triangles are equiangular, then they are similar. Or the same statement can be given as, if two triangles are equiangular, then their corresponding sides are proportional. So out of these two, both are same. Both the statements are same. So we are going to prove both. I am going to write both the statements on the board. So for the first statement, proof is there. For the second statement also the same proof comes, but an extra step is added at the end of the theorem. That's all. I will show you how it comes. So if any of the statement is asked in the examination, you can easily do it. So theorem is very simple. You will really enjoy it because you are having the knowledge of Thales theorem and its converse, and you have solved problems on Thales theorem, and you are well aware of the riders and identities. So keeping this in mind, I will enter into the theorem. Right. So before entering into any theorem, we need some previous knowledge related to theorems. So they are called as lemmas. So here in this we are going to come across three lemmas before learning this theorem, which are very important. Sir, we know all those things. We already know it. It's better to recall that with a good confirmation, and then we will proceed to theorems. Right. Let us go with lemma 1. Lemma 1. Right. So here, consider two triangles. Consider two triangles which are having the same shape and same size. So two triangles having the same shape and same size means they are said to be congruent, right? So now let us name the triangles. This is triangle ABC. This is triangle PQR, right? So in these two triangles, angle B is equal to angle Q, and AB is equal to PQ, and BC is equal to QR. It is according to the data. So in triangle ABC and triangle PQR, triangle ABC and triangle PQR, angle ABC is equal to angle PQR, AB is equal to PQ, and then BC is equal to QR, right? So this is according to the data. So if in two triangles, if in any two triangles, if one pair of corresponding angles are equal and the sides containing that angle in both the triangles are equal, then we say that these two triangles are congruent. These two triangles are congruent. So therefore triangle ABC is congruent to triangle PQR. So this is according to a postulate that is very famous, that is called SAS postulate. You have learned in your 8th standard class. And also you learned again in your 9th standard class. So this is SAS postulate. So in order to prove that two triangles are congruent, no need to prove that the 6 elements of one triangle are equal to the 6 corresponding elements of the other triangle. No need for that. So it becomes a lengthy process. So to avoid that, we develop a criteria for that. We search for a criteria where if two sides and the included angle of one triangle are correspondingly equal to the two sides and the included angle of the other triangle, then both the triangles are congruent. So no need to prove that this is equal to this angle is equal to this side is equal to, no need to prove that. Just the 3 elements, 1, 2, 3 elements of the first triangle are correspondingly equal to the 3 elements of the second triangle, then we say that the two triangles are congruent. So this is a criteria, a condition which we are going to use to prove a statement scientifically or logically. That's called a criteria. So here triangle ABC is congruent to triangle PQR, so therefore both the triangles become congruent. So if these two triangles become congruent, then it is understood that this angle is equal to this, that is angle C is equal to angle R, this angle is equal to this, that is angle A is equal to angle P, and this side will be equal to this, that is AC is equal to PR. So this is what we call corresponding parts of congruent triangles. Corresponding parts of congruent triangles, in short it is called as CPCT. This is the shortcut. So this knowledge, this SAS postulate, the knowledge of SAS postulate, I am going to consider this as lemma 1, which is required for proving AA similarity criterion. Right. So we go with lemma 2. Lemma 2, very, very important. Now, consider two lines which are parallel to each other. So let us call one of the line as L, another line as M. So these are the two parallel lines. Means even if they are extended on both sides indefinitely, they will never meet each other. They are called as parallel lines, or very simple, or two straight lines which do not have any point in common, they are called as parallel lines. Now, if these two lines are intersected by another line like this, for example, let us call it as N, at two distinct points like M and Q, like two distinct points M and Q, then we call this line N as a transversal. So, if a line intersects two or more lines at distinct points, then the line is called a transversal for these two lines. This is the transversal for these two lines. Right. So now, when two parallel lines are intersected by a transversal, then we can identify the corresponding angles. So this is angle 1 and angle 2. So angle 1 and angle 2 are the corresponding angles. So here, if two parallel lines are intersected by a transversal, then the corresponding angles will be equal. So when we take the converse of this, I have two lines. I don't know whether they are parallel or not. I do not know it. They are just two lines. Let us take it as M and N. They are two lines, and these two lines are intersected by a transversal. Let us take it as some P at A and B, at two distinct points A and B. Now, M and N, I do not know whether they are parallel to each other or not. But these two lines are intersected by another straight line, that is P, which can be called as a transversal because it intersects M at A and N at B. So now, if I measure this angle and if I measure this angle, they are corresponding angles. If I measure this and this angles, if these two angles are equal, then we say that these two lines are exactly parallel to each other. Right? So, listen to this. This is the statement and this is the converse. Right? If two parallel lines are intersected by a transversal, then always the corresponding angles are equal. This is the statement. Now, if two straight lines are intersected by a transversal in such a way that the corresponding angles are equal, then we say that the lines are parallel to each other. So, this is the statement and this is the converse, what you have learnt in your previous classes. So this is also required for learning the theorem. Right. So now let us get into lemma 3. So lemma 3, if you hear this, you will tell me, sir, I know this because it's already discussed. So that is called converse of BPT. Converse of BPT. Right. So converse of BPT states that if a line intersects, or if a line divides any two sides of a triangle proportionately, then the line is parallel to the third side. So this is the triangle we are going to take. So this call it as triangle ABC. Let DE be the line which intersects AB and AC proportionately. So in triangle ABC, AD by DB is equal to AE by EC. In triangle ABC, AD by DB is equal to AE by EC. That means the line DE is dividing the two sides of the triangle proportionately. Then it is parallel to the third side. That is, DE becomes parallel to the third side. DE parallel to BC. So this is the converse of Thayer's theorem or DPT. So these three lemmas are required for proving a similarity criterion theorem. Right? I hope you recalled successfully. Let us get into the theorem. Very, very important. Now, let us get into the statement. Right. See here, before entering into the theorem statement, I will tell you what is AAA criteria, that is criterion, and AA criterion. Let us make a clear difference about this. Both are same. First, keep this in your mind. Both are same. But we use AA criterion. Why? Very simple. Now, you have two triangles. You want to prove them that they are equiangular. You have two triangles. You have to prove that they are equiangular. So, in order to prove two triangles equiangular, what we do is we prove that their corresponding angles are equal. That is, their corresponding angles are equal. That is, this is one of the triangle, this is another triangle. I want to prove them equiangular. So if you want to prove them equiangular, I will prove that this angle is equal to this angle is equal to this, and this angle is equal to this. So if three angles of one triangle are correspondingly equal to the three angles of the other triangle, then the triangles are said to be equiangular. So this is how we can prove two triangles to be equiangular. So, here according to the similarity, for the case of similarity of triangles, if you want to prove that two triangles are similar, we have to prove that the triangles are equiangular. If two triangles are equiangular, then they are similar. That's what we have to prove. Now the question arises, sir, if you want to prove two triangles to be equiangular, is it required for proving all the three angles of one triangle equal to the three angles of the other triangle, that is corresponding three angles of the other triangle? It's not required. If three angles of one triangle are correspondingly equal to the three angles of the other triangle, then they are equiangular, hence the triangles are similar. Not required. It's enough to prove that. This is one of the triangle, this is another triangle. You want to prove this equiangular, just do one thing. Prove that this angle is equal to this and this angle is equal to this. No need to prove that this angle is equal to this. No need. Because according to the angle sum property, for example, this is some 70 degrees, this is some 50 degrees. So this becomes 50 plus 70 plus 50. So this is also 50, that is 70, this is also 50. So now, so this angle is equal to this and this angle is equal to this. It's enough. Directly announce that these two triangles are equiangular. So what about the third angle? Don't worry about the third angle, because automatically the third angle will be equal according to the angle sum property. So here 70 plus 50 is 120 and the remaining is 180 minus 120, that becomes 60 degrees. Here also 70 plus 50 is, that is 120. So 120 out of 180, if you remove 120, so you are going to get again 60 degrees. So here what I did is the angle sum property. So no need to prove that the third angle is also equal if you have proved that two corresponding angles are equal. So no need to prove that. So this is called AAA criterion for similarity of triangles, and this is called AA criterion for similarity of triangles. So if three angles of one triangle are correspondingly equal to the three angles of another triangle, then two triangles are similar. We can do this, but here we are proving all the three corresponding angles equal to each other. No need for that, because in order to prove any two triangles similar by proving that they are equiangular, for proving equiangular, just show that their two pairs of corresponding angles are equal. No need to prove that the third pair is also equal. No need. Because according to Angel's property, the third angle will be equal. So no need to prove that the third angle is also equal. So therefore, this criteria is called as AA criterion. So what is AA criterion? If two triangles are equiangular, then they are similar. This is AA criterion. So this can also be given as, A criterion can also be given as, if two triangles are equiangular, then their corresponding sides are proportional. That is, see, if two triangles are equiangular, if you prove that the two triangles are equiangular, automatically something happens. So what is that automatic thing is, their corresponding sides are proportional. Their corresponding sides will be proportional. That's automatically happens. Hence, both the triangles become similar. So, two statements comes with this. If two triangles are equiangular, then they are similar. It is understood that their corresponding sides are proportional. Or, if two triangles are equiangular, then their corresponding sides are proportional. So both the statements are related to AA criterion itself. So here we are by proving that they are equiangular, we are going to consider only two angles, not the third angle. We are not going to prove that the third angle is equal, just we take two angles are equal. Done? So if two triangles are equiangular, then they are similar. Because automatically their corresponding sides will be proportional. If two triangles are equiangular, then their corresponding sides are proportional. Hence, the triangles are similar. All is the same. Right? I hope you got the point. So, in order to prove that they are equiangular, in order to take that they are equiangular, we use AA criterion. Right? So, with this knowledge, we will enter into the theorem. So, I am going to write two statements now. If two triangles are equiangular, then their corresponding sides are proportional. That's the first statement. If two triangles are equiangular, then they are similar. That is the second statement. So both can be asked in your examination. Prove that if two triangles are equiangular, then their corresponding sides are proportional. That's the first thing. Or they may ask you, prove that if two triangles are equiangular, then they are similar. So both the statements have the same proof, but a difference in the last step. That's all. Right, we'll write the statements. If two triangles are equiangular, then their corresponding sides are proportional. And then corresponding sides are proportional. This is the first statement. Or you can use the second statement also. If two triangles are equiangular, then they are similar. Right. Both are correct. Both are one and the same. Right. So this is the statement. So a statement has two parts in it, as we have discussed in the previous theorem, in Thales theorem. So the statement has two parts. One is the first part of the statement is called the hypothesis, and the second part of the statement is called the conclusion. So by reading the hypothesis part of the statement, we are going to draw diagrams, we are going to name the diagrams, and the description of the diagram will be called as the data. So by reading just the hypothesis, we will draw the diagram and we will write the data, right? So let us get into the diagrams. So this is the diagram. So here I am using the vertices, which is used in your textbook, not those vertices. I am using some other vertices. I am going to change the name of the vertices used in the diagram. See here, theorem is important, not the name of the vertices, all those things. You should not think in that manner. As per textbook I should do it, as given in the textbook I should do it. See, come out of those things, please, come out of those things. Learn the proof, learn the concept. Name doesn't count, right? So diagram, if two triangles are equiangular, so therefore I have to draw two triangles here where both the triangles are equiangular. So as I am proving both the triangles are equiangular, here I am using AA criterion, not AAA criterion, right? So I am going to draw two triangles now. So very important. So drawing diagram is also plays a very important role. So you have to draw two triangles like this. Both should have different sizes, because at last you are going to prove that they are similar. So similar figures have the same shape but different sizes. So don't write same triangles of same size and same shape. Maybe somewhere you will be wrong, right? So let us name it. I will take it as triangle ABC. I will take it as triangle DEF, right? So this is the diagram. Now, if two triangles are equiangular, so I have drawn two triangles, now I have to show them they are equiangular. To show that two triangles equiangular, I am not using all the three angles of first triangle are equal to all the three corresponding angles of the second triangle. I am not using that. I am using AA criterion, right? So here angle A is equal to angle D and angle B is equal to angle E. So in these two triangles, two pairs of corresponding angles are equal. Third pair I am not going to discuss anything, because according to angle sum property it is understood that the third pair is also equal, right? So this is the thing you are doing. Please 100% follow this. Don't change your route. 100% follow this. You will surely get 4 marks in this, right? So now we will write the data. Description of the diagram is called as the data. Okay, now we go with the data here itself. Okay, in triangle, I have named the triangles as triangle ABC and triangle DEF. In triangle ABC and triangle DEF. Angle BAC is equal to angle EDF. Angle BAC is equal to angle EDF. And angle ABC is equal to angle DEF. Angle ABC is equal to angle DEF. Right. So two triangles I have named it, and I have showed that they are equiangular by using AA criterion. Right? Not AAA, both are same. I have used AA criterion. Right. So description of the diagram is data, that is done. Now, using the hypothesis part of the statement, in both the statements you can see if two triangles are equiangular, both the statements hypothesis is same. We will read the conclusion part of the statement. So then their corresponding sides are proportional. So you have to prove that. Right. Their corresponding sides are proportional. So go from first triangle to second triangle, because you have taken the name of the first triangle first and then you have taken the name of the second triangle second. So therefore go from here to here, right? So therefore AB by DE, you have to prove this. You have to prove that AB by DE is equal to AC by DF. AC by DF is equal to BC by EF. BC by EF. EF. Okay. So this is what you have to write when this statement is asked in the examination. If this statement is asked to prove in your examination, then you have to write, then they are similar. Or according to the second statement for this one, triangle ABC is similar to triangle DE. This is what you have to write. Improve it. If first statement is given, you have to write to prove that this one. If the second statement is given, you have to write as then they are similar. You have to write this one. Improve it. Don't write both. Look at the statement, whichever required, you write it. Okay. So now, this data what we are having here is not sufficient to prove this or this. So we need a construction, a small construction, and we are applying the concept of Thayer's theorem for proving this. So therefore, we need a copy of this triangle, that is triangle ABC, copy of this triangle inside this. We need a copy of this inside this. So I will copy this triangle inside this triangle. That means I am going to take this triangle and keep it inside. I cannot do it practically, so therefore I have to do it mathematically. So therefore I go with the next one, next step, that is construction. Okay, right. So now mark a point P. Mark a point P on DE, Q on DF, Q on DF. On what basis? Where to mark? We can mark point P anywhere on DE, but mark P here itself. Why? Because mark a point P on DE such that DP is equal to AB. This DP should be equal to AB. So this part is equal to this. DP is equal to AB. Now mark a point Q on DF such that DQ is equal to AC. So this part is equal to this. Right? And now join PQ. Join this PQ. And don't tell me, sir, BC is equal to PQ. No, you do not know it. You do not know it. It has to be still proved. You do not know it. Just I will join PQ. I don't know whether it is BC is equal to PQ or not. Let's see. Let's see in the proof. Right? So mark a point P on DE, Q on DF such that DP is equal to AB, DQ is equal to AC, join PQ. So this is the construction part. So mark a point P on DE, P on DE and Q on DF, Q on DF, right, such that you have to use the same statement, same words, don't change anything, just be with the teacher, such that DP is equal to AB, DP is equal to AB, this is very important, I will underline this, and DQ is equal to AC, DQ is equal to AC, very important again, right, join PQ, right, so this is the construction part, right, so by using this you can prove either this or that, right, so let us get into the very important part of the theorem, that is proof, very important. Now select these two triangles. In triangle ABC and triangle DPQ, select these two triangles, because when you draw a line to a triangle intersecting two distinct points on two sides of a triangle, you get a triangle here. So here select these two triangles. in triangle ABC and triangle DPQ. So here the style of naming the triangles should be strictly followed. You cannot say triangle ABC and triangle DQP. No. So name it in an order. In triangle ABC and triangle DPQ. Let us take it. So in triangle ABC and triangle DPQ. Right. I hope you can see the triangles here. In triangle ABC and triangle DPQ. Now, AB is equal to DP. AB is equal to DP. Yes, AB is equal to DP. You can write it. AB is equal to DP. So how you got this? How you got AB is equal to DP? That should be written in proof. If you are writing the reasons for every required step in proof of theorems, that's the purest form of learning geometry. So AB is equal to DP. Yes, we got it from construction. Right, next. We have written AB is equal to DP. Now, AC is equal to DQ. Yes, we have got it from construction. So AC is equal to DQ. Right. So this is also from construction. Right. Don't write short forms while proving theorems. Now, angle BAC, this angle, is equal to angle PDQ, this angle. Yes, because this angle is common angle for triangle DPQ and also triangle DEF. For triangle DEF and PDQ, this angle is common. According to data, angle BAC is equal to angle PDQ. You can see here. Sorry. That is triangle, that is angle BAC here is equal to PDQ. I am going to mention now, but angle PDQ is nothing but angle EDF. You can see. So here angle D is common angle for this triangle as well as this triangle. So therefore, I can easily take angle BAC is equal to angle PDQ. Angle BAC is equal to angle PDQ. So this is according to the data. Now, in the first triangle, I have two sides and an included angle. In the first triangle, I have two sides and an included angle. And in the second triangle, I have two sides and an included angle. That is two sides and an included angle. So, according to SAS postulate, lemma 1, please remember lemma 1. If two sides and an included angle of one triangle are correspondingly equal to the two sides of the included angle of the other triangle, then both the triangles should be congruent according to SAS postulate. Done? So, I took a copy of this. I just took a copy of this and proved that they are not different, they are same. They are one and the same by using the postulate. So, therefore, triangle ABC is congruent to triangle DPQ according to SAS postulate. So now, in order to prove these two triangles to be congruent, I used 1, 2, 3, 1, 2, 3 elements. So what about the other three elements? Which are the other three elements? So other three elements are this angle and this angle which comes here, this angle and this angle which comes here, this side and this side. These are the remaining sides. So once I prove that these two triangles are congruent, the undiscussed sides and angles which are not used in proving the congruency, now they become equal. That is, this angle is equal to this angle is equal to this. We will not discuss this. This is equal to this, which is not discussed in the proof. That is, here we are not used. So according to Cbse, I can write angle AB, that is angle ABC is now equal to angle DPQ. I give the same design. Designing is very important. You should design the diagrams in the proof of the theorems. Very important. So angle ABC is equal to angle DPQ. I can write it. Therefore, angle ABC is equal to angle DPQ. And along with that, BC is equal to PQ. BC is equal to PQ. Right? So this is according to corresponding parts of congruent triangles. Corresponding parts of congruent triangles. I have taken two elements in it. One is angle ABC. Angle ABC is equal to angle DPQ and BC is equal to PQ. Now, 75% of the theorem is over. Remaining is the climax. Very important. Now, look at this figure. Look at this figure. Here, consider the line PQ and line EF as two lines, just two lines. Here, PQ and EF are just two lines. Just two lines. I don't know if they are parallel or not. I don't know anything about it. They are just two straight lines. For these two straight lines, DE becomes the transversal. DE becomes the transversal. So, if a transversal intersects two straight lines in such a way that the corresponding angles are equal, these two become the corresponding angles. Lemma 2. Remember, please remember, lemma 2. If two straight lines are intersected by a transversal in such a way that the corresponding angles are equal, then the two lines are parallel to each other. Lemma 2. Right? Now, I will take up these two angles. But angle ABC and angle DPQ are corresponding angles. Therefore, they are corresponding angles. So therefore, PQ should be parallel to EF. Therefore, PQ parallel to EF. Now, I have proved successfully that PQ is parallel to EF. Now look at triangle DEF now. Look at triangle DEF. Full triangle. In triangle DEF, PQ is parallel to EF. I have drawn a line parallel to a side of a triangle. So, if a line, this line is drawn parallel to a side of a triangle, then this line should divide these two sides in the same ratio. This is according to Thiel's theorem. Thiel's theorem. So, PQ is parallel to EF. That means in a triangle, if a line is drawn parallel to a side of a triangle, then it divides the other two sides proportionately. Right? So, PQ parallel to EF. So, therefore, I will write the conclusion here. We will take the proportionality. Therefore, dP by DE, dP by DE sides, I am taking dP as the side of triangle DPQ and DE the side of triangle DEF. dP by DE by df should be equal to pq by ef. Yes, here. So therefore, dp by de is equal to dq by df, which is equal to pq by ef. pq by ef. So here, what is dp equal to? What is dp equal to? AB. This dp is equal to AB. Let us replace dp by AB. So dp is equal to AB. Let us replace dp by AB. AB by DE is equal to, what is dq equal to? dq is equal to AC. Let us replace dq by AC. That is AC by df is equal to, what is pq equal to? pq is equal to BC. That is from Cbse. So therefore, pq is equal to BC by ef. Hence it is proved. For the first statement, this is the proof. Now, what is the proof for the second statement? So here, I have taken two similar triangles, I have taken two equiangular triangles, their corresponding sides have become proportional, so therefore, the triangles should be similar. So therefore, triangle ABC is similar to triangle DEF. Hence it is proved. So this is the extra step for the second statement. If the second statement is asked in your examination, come until here. Write this and also come until here. If the first statement is asked in your examination, stop it here. Done? So this is the beautiful 4 marks theorem. Very important. For 4 marks, you have to practice this way. Practice this way. Watch the video again and again. 3 to 4 times watch this. You get a very beautiful, that is, hold on the theorem so that you can write the proof of the theorem by your own. Change the names. Take it as XYZ, take it as ABC, take it as some MN. Prove the theorem. Change the name, prove the theorem. Don't get addicted. I have seen in evaluations of the mathematics papers, I have seen, I am very much surprised, you will also be surprised. The students prove the entire theorem. I am asking theorem for 4 marks, they prove the entire theorem very beautifully without diagrams. Yes, without diagrams. That's totally by hearting the theorems. Don't do it, don't do it. You will not become a good student. Please learn the theorems logically, right? So I hope you enjoyed the entire session today. So this was the proof. So tomorrow we'll be going with another theorem on another criteria for similarity, which I will discuss in tomorrow's class. Practice theorems, stay home, stay safe, keep learning.